Hi everyone. In this session, we are going to start chapter 7. So in the 2 weeks ago, we finished chapter 5. In this session, we are starting chapter 7, in which we are going to learn more advanced techniques related to simulation. The model that we are going to basically capture today is related to a manufacturing process. In this model, the parts arrive to get processed, and the interarrival of the parts has exponential distribution, average 13 minutes. When these parts come to the system, we realize that 26% of them are type 1, 48% are type 2, and 26% are type 3. And so note that this interarrival time is for the parts in general, but then when they come to the system based on these probabilities, we can put them in category 1, 2, or 3. These parts have different process. In these manufacturing settings, we have 4 manufacturing cells: cell 1, cell 2, cell 3, and cell 4. These parts go through different sequence on these manufacturing cells. For example, part type 1 goes through cell 1, first gets processed over there, then cell 2, then cell 3, then cell 4. However, part 2 goes through cell 1 first, then 2, then 4, back to 2 again, and then 3, and then leaves the system. And part type 3 goes to cell 2, and then 1, and then 3, and then leaves the system. We also see here in this table the processing time of each one of these parts. So for example, for part type 1, the processing time on cell 1 has triangular distribution with mean 6, max 10, and mode 8. So all these numbers that we see here are processing times of each one of these parts on any one of these cells. All of them have triangular distributions. So one thing that you can see here is that even on the same cell, different product types have different processing times. For example, part type 1 on cell 1 has this processing time. Part type 2 on cell 1 has a different processing time, and part type 3 on cell 1 has a different processing time as well. Okay, so we want to be able to capture that. So as these parts go through these machines, they have different processing times even on the same cell. One other thing that I want you guys to know before we start is that we have one machine in cell 1, one machine in cell 2, one machine in cell 4, and 2 machines in cell 3. Okay, the 2 machines in cell 3 are different with each other in the sense that one of them is a new machine that we have bought, and one of them is an old machine. The processing times that we see here on cell 3, these are the processing times with the old machine. However, the new machine can process a part in 80% of the time that is required by the old machine. So when the new machine in cell 3 is used for processing, basically we use only 80% of these processing times that we see in this table, just for cell 3. And lastly, there is 2 minutes transfer time between all these cells that we have to be able to capture in the simulation. Okay, so let's see how we can capture this model. Let's go to Arena. We are in week 12. So please create a folder for week 12, and then inside that folder, create a model, a blank Arena model, name it as model 7.1 sequences. That's one of the important techniques that we're going to learn in this model sequences. So I want you to put that in the name of the model. So model 7.1 sequences. Okay. So first, let's create the arrivals of the entity. So bring a create module. So this is I'm going to put parse arrival. And for the entity, I'm going to name it as parts. The interarrival time has exponential distribution, average 13 minutes. They are coming to the system one by one for as long as we run the simulation from the start, and they can come to the system from the start. And then also the other basically process or main things that we have in this simulation is that we know we have 4 different cells in these manufacturing settings. So I'm going to put them as well. So at least I know the main components of the simulations are there. So I'm just going to put these processes a little toward the right because I may need this space. So this is for cell 1, cell 2, cell 3, and cell 4. Okay. And I'm going to delete these connections because I don't need them. So this is basically cell 1 processing. It's going to be a cease delay release. For the processing time, we will work on it later. However, in terms of the resources, we are going to, we know we have one machine on cell 1, right? So this is going to be the resource name. So this is going to be cell 1 resource. And I only need one of the machines in cell 1 to be able to process a part. Okay, so let's do that. We will go back to the processing times in a little bit. For now, just define the names. Okay, so this is cell 2 process thing. This is going to be cease delay release as well, and this is going to be cell 2 resource, and we need only one of these resources. Again, processing times, we get back to it later. For cell 3, cell 3 processing, cease delay release, and okay. For cell 3, we know we have 2 resources. So for now, I'm just going to name it as cell 3 resources, and we need one of the machines in cell 3 to process each part. So I'm going to call the resources as cell 3 resources, and then just press OK. And then finally for cell 4, I'm going to name it as cell 4 resource. We have only one machine in cell 4, and we need one machine or one resource to process each part. So again, for processing times, for now, I'm not going to make any change. Okay, so what I have so far is the arrival of entities and these 4 cells that I have where the parts go to get processed, and then finally they leave the system. As you know, in this system, as we said in the system, when parts come to the system, they go through different sequence of operations, right? So if I want to use it, if I want to model this system with everything we have learned so far, what should I do? So after every one of these cells, when the parts gets processed, I have to put an if-then else module and then say that, okay, now when you're done in cell 1, now check if the entity type is 1, then go to cell 2. If the entity type is 2, then go to, for example, cell 2 again. But if the entity type is 3, then go to cell 3. And then let's say they get processed on cell 2. Or I have to put another decide module after cell 2 and say, okay, now that you are processed on cell 2, if you are type 1, go to cell 3. If you are type 2, go to cell 4. And if you are type 3, go to cell 1. Okay, so that would just complicate everything or just make the model big for no reason. So we don't want to repeat these decide modules after every cell to see, okay, what is the entity type and where should the entity go next based on the entity type. We want to be able to do it a lot easier. One technique that Arena has is basically define a so-called sequence for each entity type. So if I have entity type 1, product or part type 1, I'm going to define a sequence for that entity type. So I'm going to say the sequence associated with part type 1 is to go to cell 1, cell 2, cell 3, and cell 4. And I'm going to define a separate sequence for cell 2 for product type 2. And I'm going to say, okay, product type 2 goes to cell 1, 2, 4, 2, 3. And that's the sequence associated with part type 2. And all these sequences, basically these entities, when they go through the process, they're going to carry this sequence with themselves. So when then, for example, part type 2 goes through machine 1, they're going to carry this sequence with themselves. After they're done with machine 1, we are going to look at that sequence and see, okay, that sequence says the next step is machine 2. Okay, let's send the product and let's send this part to machine 2. After the part is done on machine 2, we are going to again look at that sequence and say, okay, the next step on the sequence says the product should go to cell 4. Okay, let's send the product to cell 4 and so forth. Okay, so in other words, these parts carry that sequence with themselves. And how they can do that in the simulation environment? By using attributes. So I can define an attributes for each one of these part types. In these attributes, they are going to carry a sequence with them, which is the sequence of the operations for that entity based on their type. And as they go through the process, we are going to look at the sequence that they carry with themselves to see what is the next process that they have to go to. Okay, so now let's go back here. First, let's define the sequence and then see how we are going to use this sequence and how we are going to assign them to these entity types. Okay, let's go to advanced transfer. Okay, advanced transfer templates. If you don't have advanced transfer template available, go to File, Template Panel, Attach, and then pick Advanced Transfer, and then press and then pick Open. Okay, if you already have it, just click on it so that the Advanced Transfer panel opens. Now, in the Advanced Transfer, we see a data module called sequence. Just click on the sequence. Here we can create different sequences. So I'm going to create a new sequence, and this is the sequence for part type 1. Okay, so for type 1, part type 1, I want to create a sequence, and the sequence is cell 1, 2, 3, 4, and then exit. However, to be able to create sequence, we have to tell the simulation the location of these entities. Like, for example, when the entity is at cell 1 being processed, we have to be able to tell the simulation that this is the location where the entity is right now. And we are going to do that by creating by using the station module. Okay, so for any one of these operations that happens in cell 1, 2, 3, 4, I'm going to assign one station module just to tell the simulation that if the entity is being is going to get to station 1, it's just because the entity is going to get processed on cell 1. If the entity is going to get to station 2, that means the entity is going to get processed on cell 2. Similarly, for cell 3 and cell 4. Again, I'm going to delete these connections. So this is the station. So this is going to be cell 1 station. And I'm going to call it, for example, cell 1 or cell 1 station. And it's in a station, and that's all I want to do. Similarly, for a cell 2, I'm going to create a cell 2 station. Station name is cell 2 station. So the difference between these two, the name and the station name, is that the name is the name that we see on the arena windows. Okay. However, this name that we put here, the cell 2 station, is the name that is used in the simulation. In all the codings and everything in the simulation, this is the name that is used. So I'm just going to use the same name for both purposes. And finally, for cell 4, now each one of these stations has a cell. Now I can go ahead and create the sequence. When using the stations, I can tell the sequence of the cells that the entity has to go through. So one more thing that I need to do before I start defining the sequences is that I have to connect these stations to these processes. So I can tell the simulation that when a part gets here, this basically physical location, this basically means that the part is going to get processed, and this is the processing operation and everything you need to know about the processing on cell 1. So here I'm going to relate all of these stations to corresponding cells. So simulation knows that what each one of these cells mean and what is the corresponding processes associated with those stations. Next, we are good to define the sequence. To define a sequence, we have to go to Advanced Transfer panel. And then here in the data module, you see the sequence. So if you click on the sequence, then we have the options here, and we have the options to define the sequences. So here I'm going to double click and create a new sequence. So here I'm going to call this as part 1 sequence. Okay. So after giving a name to this sequence, now I have to identify the steps of the sequence. What are the steps on this sequence? We go to cell 1 to get processed, and then cell 2, and then cell 3, and then cell 4, right? And these are the stations that represent these processing operations. So I have to basically use these stations to define the sequence, and then the simulation will know that when I refer to this cell, that means being processed here. When I refer to this cell, that means being processed here, and so forth. So the first step then is station 1. So if you open this, you have the name of your station. So cell 1 station is the first step. And you can also give a name to your step. So I'm going to call it part 1, step 1. And here we can make different things, or we can do different assignments. When the part basically is here at this station, right before the part gets processed on these processing operations, is there anything that we want to do or not? So for now, there's nothing I want to do. When the parts get to the station, it just immediately should get processed on cell 1, and that's all I want to do. Okay, the next step is cell 2. So the name of the station is cell 2 station. I'm going to name it as part 1, cell 2. Sorry, part 1, step 2. And then do I want to assign any attribute or anything at this stage? No, I don't want to do anything else. So this is just so the second step in this sequence is cell 2 stations. The third step is going to be cell 3 station, and I'm going to call it as part 1, step 3. And lastly, it's going to be cell 4 station that we are going to go to, and I'm going to call it as part 1, step 4. And we also have to tell the simulation that after we are done here for example, for part 1, after we are done on cell 1, cell 2, cell 3, and cell 4, we want to leave the system and go. So to be able to do that, we also have to create a station for the section that when the part leaves the system. So for now, I'm going to press OK on the sequence, and then here I'm going to go back on the basic processes. I'm going to put a dispose module here, which is basically related to exit of parts. And I'm going to also assign one station. I'm going to assign one station to this dispose module. So I'm going to say this is the dispose station, and I'm going to name it as dispose station as well. And I'm going to connect this station to the dispose so that when the parts are done here, they can be sent to the dispose station, and then right here, they are going to just, since they are connected to this dispose module, they are going to leave the system. Okay. So then if I go back to the sequence module, and open the sequence I was defining, then I need to do the last step as well. After I'm done with step 1, 2, 3, 4, which are cells 1, 2, 3, 4, I'm going to send this entity to dispose station. And I'm going to name it as part 1, step 5. Okay. So then I'm done with these processes. Okay, I'm going to define a sequence for part 2. So this is going to be part 2 sequence. And for part 2, the steps that we have here is 1, 2, 4, 2, 3. Okay. So here I'm going to add the steps. Next step is station 4. Next is station 2 again. This is a step 4. And then next, we are going to go back to station 3. So this is a step 5, and this is a station 3. So we're going to go to cell 1, 2, 4, and then back to 2, and then 3. And then lastly, we are going to go to exit station or disposal station. That's a step 6. That's okay. And then one last sequence for part 3. And here we have 2, 1, 3. This is a short sequence. Station 2. So this is going to be part 3, step 1. And then station 1 is the next one. That's going to be step 2 for part 3. And then the next one is station 4, step 3, just to make sure 2, 1, 4, 2, 1, 3. So here, just make sure to edit. So this should be cell 4, cell 3 station. And then lastly, dispose. Okay, so the cells are cell 2, 1, 3. That's the order for part 3 sequence. Okay, so now I have 3 sequences, and in these 3 sequences, I specified the sequence of each one of the part types, and I'm going to assign these 3 sequences to the entities based on their types. Okay, so one more thing before we go and assign these sequences to the entities is that also when we are here, for example, when we get to cell 1, we are going to do the process or anything that is here in this process of in the cell 1 process. Next, the entity has to go, for example, to cell 2 or any one of these cells that is in its sequence, right? So, but how simulation knows to send the entity to the rest of the process? The module that is going to help us to do that is called route. So we are going to use the route module, and that is going to help us to basically to send the entities after they are done and any one of these processes to send them to the next station. So basically what we need here is that for each one of these processes, we not only need a cell to tell the simulation that, okay, this is where I am right now, but also we need a route station, a route module to tell the simulation that, okay, after you are done, use this route module to know where you have to go. So I'm going to create again 4 route modules for each one of these processes, because after each one of them after each one of these processes I need to send the entity to a different place, and these route modules are going to help me to do that. So I'm going to also connect these cells, these processes, to the route modules. So what is route? So for this one is basically route out of cell 1. And we also have a route time here, which, if you remember, I told you that the route time between all these cells is 2 minutes. And instead of just defining that here and just if, for example, the transfer time or between the cells changes, we also have to come here and change the transfer time in all these cells. I'm going to just define the transfer time as a variable and just define that variable as a transfer time here and make it easier to change the transfer time if we need to. Okay, so I'm going to just press OK here. So I'm just going to change the names for now. So this is route out of cell 2, next route out of cell 3, next route out of cell 4. Okay, now let me go back to the variables and define a variable. I call it transfer time. And the initial, what is the value of this transfer time? The initial value is 2 minutes. Okay, and I'm going to here, once I define the variable transfer time, I'm going to go here to the route, and then for the route time, I'm going to double click, build expression. It's going to be variable, current value, transfer time. And it's going to be in minutes. And for the destination type, so for the destination, instead of telling a specific station, what I'm going to do for the destination is that I'm going to say by sequence. So how for each entity that goes through this process, I'm going the simulation is going to look at the sequence associated with that entity, and then based on that sequence knows where to send the entity. Okay, I'm going to do the same for route out of cell 2. This is going to be minutes. And again, for the destination, I'm going to say, define this destination by sequence. Look at the sequence of that entity has in its attribute, and then use that sequence to find out where to send the entity. Route 3. Again, I'm going to use the transfer time, the value of the transfer time, which is in minutes. And for the destination, again, I'm going to say by sequence. And lastly here, for the route out of cell 4, the value of the transfer time or the route time is in the transfer time variable, which is in minutes, and the destination is not a specific station. look at the sequence to find out what is the destination. Look at the sequence that that entity is carrying with itself. Make sure to save as we go forward, guys. Okay, let's go back to the start of the model. An entity comes to the system, and we know that the entities, initially when they come to the system, they are parts, but then with these probabilities that they can be part type 1, 2, or 3. So usually what we do here is that we put a decide module. We put a decide module here and say that, okay, with the chance of 26% or type 1, with the chance of 40%, 46% type 2, with the chance of 26% type 3. And then we put 3 different assigned modules and say, okay, if they're type 1, now give them this entity type, give them this sequence, and so forth. So we can do all of that. However, there is another way to be able to do that, and just for the sake of learning, we are going to try another method. So in this method, we are going to use the assign module. Okay, so I'm going to use the assign module right after arrival of the entities. And in this assign module, basically, I'm going to assign the entity type and sequence. Okay, so not only I'm going to give a different entity types to each one of the entities, but also I'm going to give them a different sequence as well. Okay? So first, however, before I can assign the entity types and the sequence, I have to first find out what type of part type I'm dealing with. Is it type 1, 2, or 3? And we know the probabilities for each one of these part types, right? So what I'm going to do here is to say that, okay, I'm going to assign an attribute to these entities. And I'm going to give the name of this attribute. I'm going to say part type. Okay. So then how should I assign the right values to the part type? So how should I, for example, assign value of 1 to represent entity part part 1, how to assign value 2 to represent entity part 2, and how to assign value to 3 to represent entity part 3. So the command that I'm going to use here is disk. So disk is a command that everyone knows and is used for generating discrete random variables. And the way that this command works is that we say that, okay, disk parenthesis open, with probability of 0.26, value of 1 is generated. Then I'm not going to say with probability of 0.48 value of 2 generated. Instead, I'm going to put the cumulative probability with the value, with the probability of the sum of these two, which is going to be 72, with the value of 0.72 value, with the probability of 0.72, number 2 is generated. However, note that the simulation is not going to generate number 2 72% of the time. Simulation, basically, the way that simulation reads this is that simulation is going to generate value of 1 with probability of 26%, and then simulation is going to generate value of 2 with probability of 0.72 minus 0.26, which is going to be 48%. Okay, so that's how the simulation reads this. And also, finally, for generating value of 3 is going to be the cumulative up to this point, which is 1. And so again, I put the probability 1 is going to generate value of 3. So with probability of 26%, value of 1 is generated, with probability of 0.72 minus 0.26, which is 48%, value of 2 is generated, with probability of 1 minus 0.72, which is going to be 0.26%, value of 3 is generated. So basically, this is how the simulation is going to read this. And with these probabilities, values of 1 or 2 or 3 are generated, and they are saved in the part type attribute. So this attribute, when every entity comes, we give that entity this attribute with value of 1 or 2 or 3 to define if that entity is part type 1 or part type 2 or part type 3. Now I also want to assign different sequences to the entities. Okay, so one thing that we said here was that a sequence also can be saved on an attribute. A sequence is something that an entity carries with itself, and throughout the whole process, every time we want to find out where is the next step for the entity, where should it go next, we're going to look at the sequence. So here I'm going to create again another attribute for each entity that comes to the system, and this attribute is going to get a sequence. Okay, so here one of the values that we have here right away is entity sequence. Okay, so we are going to pick that. So that's entity sequence. So that's one of the built-in attributes for an entity. Okay, so we already have worked with a couple of these built-in attributes: entity picture, entity type, for example, entity sequence is another one. So this attribute already has a name and is called entity sequence. And what are the values that we want to give to this attribute? So we already have defined, so I'm just going to press OK here and press OK and go back to the sequence data module. And in this sequence data module, you see I have defined 3 sequences for part type 1, part type 2, and part type 3. So, but here I have only one assign module to assign the correct sequence to these entities. If I had a decide module here and 3 different assigns modules, okay, in each one of the assigns modules, I would just assign one of these sequences that have been defined here, right? But I do not have 3 different assign modules after a decide module here to easily say, okay, with these properties, I'm going to give this value to the attribute, or this value or that value. So what we need to do here is to define a set or an array of these sequences. And if I do that, then here I can just come and say that for this entity sequence attribute, pick the first element of the sequence array, or pick this first element or the second element or the third element of the sequence array, and then put them in this attribute. Okay, so what I'm going to do then is to create a set of these similar objects, which are basically sequences. If I go to basic process for the set, if you click on the set, okay, here we could potentially create a set. So if I just click here, you see that when I say, okay, it's a set of different things, it's a set of, here I have the options for resource, for entity type, which we have done all of that, for the counter and things like that, but I don't have the options for a set of sequences, right? So I'm not going to do that using the regular set definition of a set. So let me just delete this one because we're not going to use it. What I'm going to do is to go to advanced process, and here there is advanced set. So when I click on advanced set here, then I have the possibility of creating the sets. So I'm going to call it as sequence set. So this set is a set of sequences. So here I have the option to create a set of queues, a set of storages, and if I want to create a set of other objects, I just pick other. Okay, so other fits these conditions, which is a set of sequences. And here I need to specify the sequences that basically fall in this set manually. So I'm just going to add, and then here I need to know the name of the sequences I identified, and I put them here. So here is the name of the first sequence that I identified. So I just copied the name of the first sequence and I just paste it here. So I always recommend to just copy and paste the name of the sequences instead of just typing them, because again, you can have typos and so forth. So for example, so I can go to advanced transfer, click on the sequence. Here is the name of the first sequence that I created, right? That I had copied that. Here is the name of the second sequence that I created. I copied that, and then I go back to the advanced process. Here I click on the advanced set, and in this advanced set that I was creating, I need to put the name of the second sequence that I have created for part type 2, add, and here I'm pasting the name of the second sequence. and then add again, and here is the name of the third sequence. Okay. So here basically you have to put the name of the 3 sequences that you created for part type 1, part type 2, part type 3, and now you have a set of these sequences. And this is just like an array that has 3 elements. So if I say sequence set array 1, I'm referring to the first sequence, which is for part-time. If I say sequence set 2, I'm referring to the second element of this sequence, which is the sequence we defined for part 2. And similarly, the third element of this sequence refers to the sequence we defined for part 3. So we put them in that order. So let's press OK. So now I have an advanced set defined. So now I can go back to the assign module and just use this set to assign the right sequence to these entities. So when the entities come to the system, on line 1, we just learned that how to give them a different attribute of 1, 2, or 3. The value of this attribute is 1 or 2 or 2, 3, and to identify the part type. Okay, so the name of the attribute is part type, and based on this probability, this attribute gets value of 1, 2, 3 corresponding to part type 1, 2, 3. And then I need to each one of these entities that come, I need also to give them another attribute in which I'm going to put the name of the sequence that they're going to carry with them. So when these attributes come to the system, they're going to have another attribute, and then we use this built-in name for that entities, which is called entity.sequence. In that, I'm going to put the name of the sequence that each one of these entities are going to carry with themselves. That is going to help them to know where they should go next. So here, first I need to identify the name of that set. The advanced set that we define, we named it as sequence set. Okay, so that's the name of the set of sequences that we define. So now, which one of the elements of this set is going to be placed in this attribute? Remember, this set has 3 members: member 1, member 2, or member 3. Member 1 refers to the sequence for part type 1, member 2 refers to the sequence for part type 2, and member 3 refers to the sequence for part type 3, right? So which one of them should be used to be assigned in the entity sequence of an entity? So here we know that in the first line we already defined a part type to the entity. So when an entity comes to the system, first we run the first line. In the first line, we give a value of 1 or 2 or 3 to the part type attribute to specify if this entity is type 1 or 2 or 3. Now, given the fact that I know the value of 1 or 2 or 3 in the attribute part type, if I want to assign the right sequence to the entity as well, here I can use that attribute and I can say I'm going to know which element of this set is going to be used if I'm going to look at part type. So part type identifies if the entity is type 1 or 2 or 3, and then here if it's type 1 or 2 or 3, then I pick the first or second or the third element of the sequence set, and then as a result I pick the right sequence in that set to assign it to the entity. The other thing that I want to do here is to assign an entity type to this entity part that comes to the system. If I assign different entity types based on their type, if they are type 1, 2, 3, if I assign different entity types to them, you have seen that when I run the simulation at the end, simulation is going to just generate all the statistics and everything for different entity types. So if I want to just easily see the results for different entity types, I want to assign them different entity type as well. And I can do it here. However, similar to the story that we had for the sequence, I only have one assign module here. And if I want to use this one assign module to assign entity type, again, I'm going to say, okay, I'm going to define a vary attribute, and this attribute is going to be a built-in attribute. I can define it, then its name myself as well, but we are going to just use a built-in attribute, which is entity type. So now, what I want to do, I want to give different values to this entity type, right? So for part one, I want to maybe say that, okay, the name of the entity is part one. For part two, I want to say the name of the entity is part two. For type three product, for type three parts, I want to say the name of the entity is part three. But how can I do that? Here I just have one line that is going to run, and I have to assign three different values to these attributes. How can I do that? We are going to use the same logic that we use for the sequence. We are going to define a set of these entity types, and then all I need to do here is to refer to that set and just say which element or which member of that set you have to look at. Is it going to be the first element of that set, or the second element, or the third? Okay, so what I'm going to do then is that I'm going to go back to the basic process panel. Here I have a set data module. So this is a set of entities, so we can just create it using the regular set. We don't need to go to the advanced set data module. So here I'm going to create a new set. This is going to be the entity set. And this is going to be the set of entity types. And now I'm going to create, what are the members of this set? I'm going to give it three members. First one, I'm going to call it part one. Second member, I'm going to call it part two. Third member, I'm going to call it part three. Okay, so in this set, which I'm going to call it entity set, I created three entities, part one, part two, part three. So again, this is an array of size three. When I refer to the first member, I refer to part one. When I refer to the second member of this array, I refer to part two. When I refer to the third member of this array, I mean part three. Okay. So press OK. Before we go back to the assign module, I want you to check the entity module as well. You see, initially we only had one entity in this entity data module, and that was part. That was the only entity we had in the system. But right now that in the entity set, I define three new entities, part one, part two, part three. They were automatically added to the entity data module as well. Okay, so that basically means you don't need to create these entities initially and then go to the set and say, oh, these are the members of this set. You can just create them in the set, and they will automatically be added to the corresponding data module as well. Okay, now let's go back to the assign module and then give different attributes, give different entity types to these entities. So here I'm going to add, again, this is going to be an attribute. This is going to be the entity type. I'm going to just use one of these built-in attributes, entity type. And here, the name of the set that we defined is entity set. Okay. Here, that's the name of this. That's the name of the set that includes three members, right? Part one, part two, part three. So if I just say member one, it refers to part one. If I just say member two, refers to part two, and if I just say member three, refers to part three. Okay. However, how can I tell the simulation that for each entity that comes to the system, assign the corresponding entity type? I can use again the part type attribute. So then if I press OK, this is what happens. When entities come to the system, initially we assign them a part type, which takes value of 1, 2, 3, representing if it's part 1, part 2, or part 3. Then we assign them the right sequence from this sequence set. Okay. And then how do you know which member of the sequence set we have to pick? I'm going to look at the attribute part type again. If it's 1 or 2 or 3, I'm going to pick member 1 or 2 or 3 of this sequence set. And then lastly, when I want to assign the entity types, I'm going to, again, look at the entity set. From this set, which member I'm going to pick? I'm going to again look at the part type. If the part type has value of 1 or 2 or 3, I'm going to pick the member 1 or 2 or 3 of this entity set, which corresponds to part 1, part 2, part 3. So as you can see, then the order of these assignments matter here. We have used part type attribute in the second assignment and the third assignment. So I definitely have to define the part type attributes first in the first assignment before I can use it in the second assignment or the third assignment. So the order of these assignments matter. The first line that we have definitely should be the first line and creates or defines the part type attribute, which takes value of 1, 2, 3. And then we can write any of the other 2 assignments. They can be any, we can write any one of them. And in these 2 assignments, as you can see, I'm using part type attribute, which I already have defined here. So pay attention when you are using, when you define a couple of things in the assign module, pay attention if the order of those matters or not. And also lastly, again, just pay attention that if you want to just use one assign module to give different values to an attribute, for example, to an attribute that can carry the sequence or an attribute that can carry the type of the entities and so forth, the only way to do it is that to first put all those possible values that you want to define to that attribute, put all of those possible values in a set. And then when you get here in the assignment, then pick which member of the set you want to be assigned to these specific entities. When an entity comes to the system, the first line is run. We know the entity is type 1 or 2 or 3. Then we pick the corresponding member of these 2 sets to assign to that entity. So that's basically the only way you can assign different values to the entities using just one assign module. And so when the entity has come here and already has all these sequences and entity types and so forth, then we need to send the entity to the corresponding stations so that it can start the processes. So then to be able to do that, I need a route module to be able to send the entities. So I need a route module here. And this route module basically is the start route. And if you remember, we put this time, the 2 minutes time in a variable and called it transfer time. So I'm going to go to the build expression, variables, current value, and that's the transfer time. Okay, so that's the name of the variable that has this 2 minutes of transfer time. So make sure to change the time to minutes as well. And then for the destination, here I'm going to choose by sequence because each one of the entities already has been assigned a sequence, so the entity has the sequence. So we are just going to look at that sequence and see where is the next station that the entity has to go. Okay, so let's also connect these modules together. So, okay, when entities come to the system, we assign the corresponding attributes to the entity, then they start the route. Then based on their sequence that they have, they go through the right cells, and then they finally are ready to leave the system. Okay, so so here we're basically are done, we have done most of the things. The last part that is left is the processes at this point. Remember when we defined the processes, we didn't define any processing times, and we also didn't do a complete job in terms of the resources that we need and so forth. So we are going to take care of that, and then the model will be done. Okay, so for part, there are different ways for us to capture these different processing times for different part types on these cells, okay? So we are going to basically try different methods just for the sake of learning. So we know that cell 1 has different processing times for part type 1, and then a different processing for part type 2, and a different time for type 3. Okay, so I can define these 3 processing times in an expression of dimension 3 and then use that expression in the processes for cell 1. This is something we had done in previous homework as well, and also in your exam you had similar scenarios as well. Okay, so I can define an expression here, and I can name this as cell 1 processing time. And this expression can have 3 possible values. And what are those possible values? In the first value, I'm going to put triangular 6, 8, 10. In the second value, I'm going to put triangular 11, 13, 15. And in the last element of this expression, I'm going to put triangular 7, 10, 13. Okay. So basically, I created an expression. I call it cell 1 processing time. And this expression has 3 elements, element 1, element 2, element 3. Element 1 shows the processing time in cell 1 for part type 1. Element 2 shows processing time on cell 1 for part type 2. Element 3 shows processing time on cell 1 for part type 3. So then, after I assign this processing time, which I'm going to copy the name of this expression here. Press OK. So now here, when I want to assign the processing times for each one of the entities that come to cell 1, so here then I say to use an expression, and the processing times obviously are in minutes. They are value-added operations, and this is the name of the expression. And how do I know which element of the expression I have to pick? Is it going to be the first element of the expression, or the third element, or the second element, or the third element, because each one of them is a different distribution? I'm going to again look at the attribute part type. The attribute part type has value of 1 or 2 or 3 for product type 1, for part type 1 or 2 or 3. So when those values of 1 or 2 or 3 are used here, the right value are going to be used from the expression of cell 1 processing. So we take care of that this way. And make sure to save, guys, as we proceed. How about cell 2? For cell 2, as well, we see that part 1. So for cell 2, we see that this is the processing time of part 1. This is the processing time of part 2. And this is the processing time of part 3. So we can definitely do something similar. We can go to expression, define an expression of size 3 and do the same thing. Or just for the sake of learning, we can actually use the sequence that we define to do that. So let's go to the sequence module. So here, we're going to first look at the sequence we defined for part 1. Okay, so this is the sequence. The part goes to cell 1, then cell 2, then cell 3, and then cell 4, right? For cell 1, we already defined the processing time. Using the expression that we defined, the processing time is identified. And then the entity from there goes to the route and then to the cell 2 station. Okay, as soon as the entity gets to the cell 2 station, and before the entity gets to this processing on cell 2, we can identify the processing time of this entity, which is type 1, part type 1 entity on cell 2. So to be able to do that, I can assign a new attribute to these entities. I'm going to call it, let's say, process time. When the entities come to station 2, so to cell 2 station, I'm going to put the right value on that attribute, which is the processing time for example, here, since this is a sequence for part 1, I'm going to put the processing time for part 1 on cell 2, which is a triangular 5, 8, 10 minimum mode maximum. And so I'm going to put this random variable in that attribute. And then when the entity goes to goes to the next station, cell 3 station, which is here, I'm going to put a new value in that attribute, which is going to be the processing time on cell 3. And then as a result, the entity will have this new processing time on cell 3. And then when the entity goes to cell 4, I'm going to put a new attribute in the value of that cell. And then as a result, it's going to use this value for the processing time on cell 4. Okay. So let's go back here. So initially, as we said, for cell 1, we are already good. We already defined the processing time using expression. Now the entity is at cell 2 station. The entity is here. Before the entity gets into cell 2 processing, right here, I want to do an assignment. What is that assignment? I want to define a new attribute. I'm going to call that attribute process time. And what am I going to put in that attribute? I'm going to put a triangular 5, 8, 10. Okay. So then this is what's going to happen. So basically we say that, okay, you are now at cell 2 station. This is where we are now, cell 2 station. And this is the step 2 of the sequence associated with part type 1. And then right here, I want you to also do this assignment as well, to also define a new attribute, call it process time, and then put this value in that attribute. Okay, so that's what I'm going to do here in step 2. And let's press OK. And now when I go to the processing time, when I say that, okay, I'm going to use one resource, I'm going to call it cell 2 resource, blah, blah. And then for the process, I'm going to use expression. And then here for the value of that expression, I'm going to use that attribute, which I'm going to identify here. So I'm going to go to the attribute, value, and this attribute is going to be the process time attribute. So here, then when we do the processing on cell 2, then the processing time is going to come from this expression. The unit is minute. Make sure to put the right unit of time. It's a value-added operation. And the value of this processing time is going to come from the process time attribute. Okay. I need to go back to the advanced transfer sequence. And again, I look at sequence for part 1 now. The entity is done processing on cell 2. The route based on the sequence has sent the entity to cell 3. So we are still looking for part 1 sequence. And the third step is going to cell 3 station, which is here. On cell 3 station, again, the processing time on cell 3 is this much, triangular 15, 20, 25. So what I'm going to do again here is that I say that, okay, I also not only I'm at station 3. At this point, I also want to do an assignment. I want to assign a value to this attribute, which we already have defined process time. And here I'm going to define it as triangular 15, 20, 25. Okay. That would be the processing time. That will be assigned. So it's okay to do this assignment on the same attribute. So although I have used this attribute here for the for the processing time on cell 2, but I'm done with processing time on cell 2. So I'm going to rewrite the value of that attribute with this new distribution. And note that this is an attribute. This is not a variable. This is an attribute. So every entity carries just one attribute. We call it process time. And after the entity is done with an operation on a cell, we are going to rewrite the value of that attribute so that we can put the processing time on the next operation on that attribute. So this is an attribute, just pay attention to that. And similarly, when the entity gets to cell 4 station, I again want to assign a new value to that attribute, which is process time. And the value in the new value is triangular 8, 12, 16. Okay. And that's the processing time for step 4. And when we go to the dispose station, we shouldn't worry about anything. So then all I need to do is to again go back to cell 3 and just say that the processing time is an expression which is in minutes, and the value of this expression is coming from this attribute that we have defined, and that is process time. The same for cell 4. The processing time is an expression, the unit is minute, and the value of this expression is whatever is in the attribute process. So this is for entity type 1. We did that for entity type 1. I need to do the same for entity type 2. I need to go to the sequence for entity part type 2 and just say, okay, for station 1, we are good. We already defined the processing time using an expression. For station 2, before the entity gets to the cell 2 for processing, right now we are at cell 2 station. Right here, I want to put the right value on that attribute that has the processing time. And that is triangular 486. And then for cell 4, 15, 18, 21. And then back to cell 2 again. The processing time here is back to cell 2. The processing time is 6, 9, 12. And lastly, for cell 3, 27, 33, 39. Press OK, and then save. Yeah, so we made the changes for part 2 as well. So when if an entity comes, that is part type 2, when the entity goes through the process, this part 2 sequence is used. And then when these steps of the sequence are executed, these assignments will be done as well. The processing time we need on each one of cells will be assigned as well. So make sure to save before we proceed. Then let's go to cell 3. So for the cell 3, for now we are at cell 2, and in cell 2 we have to identify the value of the attribute process time, and the time is 7, 9, 11. And then for cell 1, we already know that the processing time on cell 1 is identified using the expression that we defined, so that we don't need to worry about cell 1. And then for cell 3, we are at cell 3 station. We have to change the value of the attribute process time so that when we get here, we have the right value in the process time. So for cell 3, we are going to also identify the value of process time, and this is going to be triangular 182328. So this is the processing time of the entity type 3 on cell 3. Okay, so when the entity is at cell 3 station, this is going to be the value of processing time, which is exactly what we have here, 182320. And as a result, by updating the value of the process time on these stations, the right processing times for part 3 entity type is used. Let me also check here. So let me just say this is a step. Let me just see for this position. I don't have a step. That's okay. We don't necessarily have to have a step name, but I'm going to just say part 3, step 4. Okay, so for this position, which we have at the end, I had forgotten to put the name of the step name, and I just put something, but it's not necessary. So press OK, make sure to save, guys. So then we are good in terms of process times for all the cells. Cell 3 as well, and cell 1 will come from this expression. And the very last thing that we need to identify here is that for cell 3, if you remember, we said that we have two resources, a new machine and an old machine. The processing times that we saw here on cell 3 are the processing times with the old machine. The new machine has a processing time which is 80% of this time, so it's a faster machine. So now we want to see how we can do that. So to be able to do that, I'm going to define a set of two resources for cell 3. So let me go back to basic process and the sets. Here, I'm going to define a set of two resources. And again, I'm going to define a set because if I just set, if I just say here, if I just say, oh, cell 3 resources, if I just go to the resource, and for cell 3 resources, and I just change the capacity to 2, I can't pick which resource I'm working with, right? So I don't have that option. So if I have two resources here for cell 3, old machine and the new machine, and I want to definitely know which one is the one that I'm working with because they have different processing time, then I need to identify two resources for cell 3, the new machine and old machine, and I need to identify a set based on those resources. So I can potentially define the resources here first and then go and define the set, or I can just go define the set right away, and the resources that I put in the set will be automatically created in the resource module as well. So here I'm just going to do it this way. I'm going to create the resources here. So here I'm going to change the name of this resource. So cell tree resource old. I'm going to create another resource. I'm going to call it cell tree resource new. So this is for the new machine and the old machine. So I'm creating these two new resources, and then I go to the set, and right here I want to create a new set. I'm going to say a cell tree resource set, and this is a set of resources, and here I want to add these elements. So this is a set of resources. So this is going to be I'm going to put cell tree resource old first, and then cell tree resource new. And here, then I define a set, which is a set of resources, cell tree resource old and new. These are the set of resources that I'm using for on cell tree. Okay, let's press OK and save. And just pay attention again that the first resource is the old one and the second resource is the new one. Okay, so now let's go back to cell tree operation, and here instead of using a resource, I'm going to say that I'm going to use a set. And what is the name of the set? It's going to be cell tree resource set. And then here I'm going to save the index of that machine that is being used in the cell tree index. Cell tree index. Okay, so this is the index that is going to save the index of the machine that is being used on cell tree. If index is 1, that's the old machine, that's the order I put them in the resource set. So I put the old machine first and the new machine second. If it's the first machine, the index is going to be 1. If it's the old machine, the index is going to be 1. If it's a new machine, the index is going to be 2. And for the selection rule, I'm going to put it as cyclical because so this basically means that they are going to take a turn. The old machine and new machine are going to take turn in processing the parts. And if one of them is busy when a part comes, the part definitely goes to the one that is idle. It's not going to wait. Even if it's not the idle machine's turn, the machine is going to go to the idle one and gets processed. However, if both machines are idle, then the simulation will use the turn to find out which machine is the one that has to pick up the part. So it uses the turn rule. Okay, so that's basically what it means here. So what I have done so far is that I told the simulation and that the resource for this operation is coming from this set, and when the simulation pick the resource, it's going to save the index of that resource in this attribute for me. Okay, now before I update the processing time, I'm going to go to variables, and here I'm going to define a new variable. I'm going to call it factor. Okay, and I would say this variable has 2 elements. So this is basically an array of size 2. So here I'm going to put some multipliers that I'm going to use later to define the processing time on cell tree. So the first value that I'm going to put here is 1. And the second value that I'm going to put in these 2 arrays of size 2 factor is going to be 0.8. And how am I going to use these 2 values? Remember, we said that if I'm using a new machine, the processing time is just 80% of the processing time of the old machine. So we already have defined the processing times of the old machine for cell 3 on the process time attribute. So if I'm using a new machine, I want to multiply that by 0.8. And if I'm using an old machine, I just want to multiply that by 1, meaning that I don't want to change the processing time at all. And the order I put here 1 or 2 is because in the resource set that I define, the first, if I go back to the resource set here, you see, in the resource sets that I define, I put the first resource as old and the second resource as new. So if I'm using the first resource, which here in cell 3, if I'm using the first resource, this cell 3 index is going to return index 1. If I'm going, that's the old index, that's the old resource. If I'm using the second resource, that's the new resource, and the cell index returns 2. So that's why I put the first value of 1 in the factor multiplier, which is corresponding to the old machine, and factor 0.8 in the second element of the factor, because it's corresponding to the new machine. And right now here, I'm going to, for cell 3 processing, I'm going to multiply process time by factor, which is that multiplier, and which index of the factor, I'm going to pick the right index from the cell 3 index that I already defined here. So basically what happens here is that the entity comes and is going to get processed. Right here, I tell that, okay, for the resources to process this entity in cell 3, pick them from this set. And this set, I already have defined it, has 2 sets, 2 machines, the old machine, which is the first one, the new machine, which is the second one. And then I save the index of those machines here in this attribute. So the value of 1 means the old machine, value of 2 means the new machine. So when I come here, then I need to multiply process time by a factor if this machine that has been used for processing is the first machine. That means it's the old machine, so the factor, the first element of factor is 1, meaning that I'm not changing the processing time, just multiply it by 1, so use the same value that I save on the processing time. But if the cell 3 index here is 2, that means the second resource in the resource set has been used, and the second resource is the new machine. So the factor, the second element of factor returns 0.8, and that's the one that I'm going to multiply by process time, because the processing time on the new machine is just 0.8. It's just 80% of the processing time of the old machine. So basically that's how we are going to take care of that part. Make sure to save, guys, as we proceed. Okay, we want to run this simulation model for 32 hours. And each day has 24 hours, and I want to observe the results in minutes. Okay, now let's run the model and see what we get. So after running the model for 32 hours, the number of entities or number of parts that have left the system is 137. We get the results for part 1, 2, 3 separately. And also we get in terms of number of entities that came in, for each one of the parts top 1 to 3, number of entities that left out, and number of entities that are in the system as work in process. As you can see, a larger percentage of parts are part 2, 48%. So we have more of work in process related to part 2. Also, in terms of the queues, we can see the waiting time in each one of the queues for each one of the cells. We can see the average number of parts waiting in the queues to get processed. And also in terms of the resources, we can look at the utilization of the resources. We can look at the instantaneous utilization or the scheduled utilization. And if you remember, in one of our previous discussions, in previous sessions, I told you that it's better to look at scheduled utilization. In this scenario, since our resources are working across the whole simulation time, there is no schedule. Both instantaneous utilization and scheduled utilization are basically giving you the same numbers. But if you are working on a model when the resources are using some schedules, it's better to use scheduled utilization because it looks at utilization of the resources during the time they have been scheduled to work. And here also we can see the utilization of the resources for all the cells, and for cell tree, we can see the utilization for the new machine and the old machine as well. So some of the main things that we learned in this model was, one, the concept of sequence, that the fact that we can define sequence and entities can carry that as an attribute, and then using the sequence we can see what is the next destination that these entities are going to go to. If we want to define the sequence, then we have to make sure every location that this entity is going to go to is going to be identified by one station, because the sequence is going to be a collection of these stations. And one other thing that we learned was that if we are not going to use if we are not going to use the decide module to assign different attribute values to the entities, or to decide what percentage of entities are which type, we can potentially use disk command. So this produces some integer random variables, and so here the random variable takes values of 1, 2, 3, and we can basically decide on what type of entity we have using this command instead of using a decide module. And also pay attention that if we are using just one decide module to assign different values to one attribute, for example, to assign different possible sequences to the entity.sequence this attribute, or to assign different entity type to the entity type attribute. If we are going to do that, then potentially we can put all of those sequences or all of those entity types in one set, and then refers to each member of that set as a member of that array. For example, here, the sequence set is an array that has 3 sequences, and here by using the sequence set part type, I know which one of these members I'm referring to, and that enables me to assign different values to this attribute using just one assign module. So this is another important feature of the arena that you guys got familiar with. And lastly, how potentially you can assign different processing times on the machines that are used for the same type of operation. So here in cell tree, we do the processing. We can use either a new machine or an old machine, and each one, then depending on the type of machine that we use, the processing time would be different. We also learn how potentially we can capture those scenarios. So this is the end of the model 7.1 from chapter 7.